Welcome. Great to have you here. We will have some people joining during our, let's call it our presentation. The room will be occupied and we have some logistical challenges, meaning people are still moving between a lot of buildings on the high-tech campus. But first of all, I want to say welcome and thank you for being here on the AI Summit. So we are the host of the expert track. So it's not expert for experts, but we have the luxury to invite experts from the field who will talk about some key developments in the field of AI, potentially some solutions and some visions they have on how AI would transform the way how we work, how it will influence work. And I think what I found very interesting when we spoke with Heiko, that he said, hey, we are now starting to match human-like capabilities in the field of logistics. Well, we all know it's a very complex field. Let me first introduce the AI Innovation Center. So I was part of a company on the campus, and as part of the survey and building the vision of 2030, how high-tech campus could support, let's call it the residents, and what are the emerging technologies like artificial intelligence and the metaverse would influence the need of talent, services, potentially an ecosystem that can help to orchestrate and deliver value to the residents to make sure that we help them to adopt the field and the knowledge needed for artificial intelligence. So last year we kicked off, April 21, we kicked off, right, on how could we, as AI Innovation Center, drive. And it's good to see that we have a few individuals who are here already for more than 18 months with us, joining us in many of the events. But we are organizing events where we share knowledge, trainings. We build an ecosystem of fundamental research, universities, companies, partners, providers like Microsoft. I think the keynote today showed already how AI and metaverse will potentially transform the way how we work. Gaia X, Catena X. But also what we do is trying to organize how can we help you in applied AI. As part of the Innovation Center, we have 13 startups, scale-ups, who will be invited today to join us in the roundtables. And they will tell what they have done to change the way of retail, logistics, or how they help companies transform. One of the parties today will be also VBTI, where VBTI has organized jointly with us some trainings on sharing knowledge, and therefore a lot of new opportunities have ceased to exist or start to exist. And therefore we want to present you a few of our, let's call it, long-term partners that we have worked with. So Heiko, I think I want to invite you to come forward to present your company around smart robotics. And I think just briefly when we met, you explained that robotics are moving into the field of manufacturing into logistics and a significant shift, and that you see that as a huge opportunity for your company, but also on how the way you work with manufacturing and logistics itself.
Yeah, correct. Hello. That's super. Is this working?
No.
Well, I just raised my voice. Wow, thanks. That's actually super exciting for me because we are currently at the point that the technology is coming to a level that we can indeed come to sort of human performance, and that actually we now can create value for our customers to actually start automating their logistics processes. And there's a lot of people around there to still do the work, and there's actually too few because we have quite a bit of shortage there. So the whole robotics community is currently looking to how are things moving actually from serving automotive for like 95% to moving to serving logistics for like 95% of their business. Yeah. So it's super exciting how that trend will emerge from now.
Yeah, one thing that struck me during your conversation is that AI was the enabler to enter a certain market. You use deep learning to solve a problem that you first could not solve by any of other available technology.
Yeah, correct. That was especially the case in the fashion industry, where we are, I will show a movie as well, but we're doing pick and place challenges, and then we were confronted with a lot of bags, like in a box, and it was super difficult to actually sort of hard code the algorithm, the software, to actually deal with this. So actually, I think the first one I talked to was Albert itself a couple of years ago. You might not even remember this specific moment, but I was like diving into how to solve this. And then indeed, deep learning, actually working with C-Boost, all friends here, you know, it's an ecosystem. I needed to say that as well. No, but it's really that gave us the opportunity to actually really get to the level, to the performance level that we are at now.
Yeah. Hey, so the question I asked both of you, but also especially Why are you going on stage?
Why? Because well, actually because of this. Because if you look at robotics, there's a lot of things that are to be connected. You know, it's the motion of the robot. It's the perception. It's the brain of the robot. So you need such a lot of skills, and to do that yourself is like impossible. So I have quite a bit of brilliant minds in my team now, but I can't do it all by myself. So I definitely need the work and the brains of a lot of others to actually do it together. So being on stage for me is the reason to share my challenges, because I still have a lot of things that haven't been solved yet, and maybe I spark some things like, hey, you have an idea to help me, or maybe I have solved some problems that are actually your current problems as well. So I think mainly to inspire others and to be inspired.
So take your time, and maybe you can inspire some others.
Take your time. You already stole half.
They were late.
That's true. It's the audience. So what I want to do in this talk is especially tell you my story on how we start working with AI and how we are working and what we do with it. Let's see how this works. So a very short introduction about myself. So I have a technical background. Worked at a couple of companies. I don't have a screen here, is it? I have to look there. And about 7.5 years ago, I founded Smart Robotics. We grew the company up to 70, a team of about 70 currently. We have quite a bit of robots in the field already, mainly in Europe. About 15 countries we are exploiting to. And we moved to fully focus onto logistic challenges. And what are we doing? It's all pick and place challenges. So it's about robots picking stuff and putting it somewhere. We're doing that with a lot of different robot arms and a lot of different situations. But in essence, it's picking unpacked items or packed items, putting them on a belt, stacking them neatly on a pallet, so making a Tetris puzzle actually. Or getting them from a roller cage while avoiding the sides of the roller cage, which might be all bent and stuff like that. So quite complicated challenges how we look at this. And why are we doing this? Well, obviously because logistics is growing super fast. So if you only see, I just took bol.com and Coolblue because we all probably know these from it's a local e-commerce. If you see the growth of these companies, and of course I didn't plot 2022 because there's a little dip actually currently, but the growth is like enormous. So the need for solutions to actually keep on growing here and keep on serving the consumers is big. And what's also good for me as a company is that the pain that they are feeling is actually growing as well, especially depicted here. Just depicting the shortage of personnel which is growing rapidly as well. And when there's a pain and a need, there's a business, of course. And the other thing is that as a company, we always say we want to be market leaders. So we have we are here to become big and to become important, and that's actually super difficult to do that on a really common problem that everybody might be able to solve. So we're looking for the complex problems, which actually logistics provides us. Because if you only look at this picture, just think about how you're going to automate such a challenge, which is now currently being done at these postal offices, for instance. It is quite a challenge. So zooming in a little bit on why it is such a challenge. So if you look at automotive, there's a lot of robots already in the fields. It's really common. But if you look at logistics, then you don't see still a lot of automation. It's like amazing if you look at these, how many people there are working. And this is like a really typical example of lots and lots and lots of people there working. So it's almost amazing how they can still keep on their growing that rapidly. But why is this? Why aren't there a lot more machines or robots or automation solutions already in there? That's mainly because the things that they do and that produce are so different. So automotive again, a lot of similarities. But if you look at the logistics, it's a lot of variance. So actually programming a machine to produce such a thing is you can do it with a lot of hard coding. But if you start trying to hard code how to how to actually grab a specific item, it's like impossible, because any other item you need to grab in a different way. So this is super challenging. So that's why currently, and that's the interesting thing I said in my introduction, currently we see that we are, from a technology point of view, we are getting to a level that we can actually deal with these situations. And that makes it super interesting. So the challenges that we have is variation. It's variation in the products. So here again, or the image I showed you above before, but it's also the variation in tasks that an operator is now currently doing. So if you only look at this person, it's taking it's first selecting the right box, it's folding the box, it's actually putting something in, it's taping it, it's sticking it, it's doing a lot of things at the same time. So both the variation in tasks and in the product makes this a really difficult thing to actually automate. But at the same time, it is very repetitive. So it is, you do have a lot of variation, but at the same time, it's continuously the same movement. So typically such an operator does the same task every couple of seconds, which of course makes it boring. So it's not something that you want humans to do. You actually would like to have machines to do it. And now I'm getting to the point why we started using AI, because for me, there are three things why I want to use AI. And this is in situations where we have a lot of repetition, because if you have repetition, you can actually learn, and you can actually start learning for the future. But it's also the situation where you have a lot of variance, because if you wouldn't have a lot of variance, you could simply hard code the behavior, like in the welding machine. You wouldn't need AI. AI would then be an overkill if you wouldn't have a lot of variation. And the third thing for me also very important is that you do not require an optimal solution, because from AI we always get a solution, but it's not necessarily that the algorithm gives you the best or the optimal solution. So if you, for instance, would be welding a car, and you would try to make a manufacturing line to weld 100,000 of different cars, then you would have a lot of variation, you would have a lot of repetition, but you'll never sure where you put the weld. Well, that's not going to work, because you really need to require a very high level of performance there. So these three are key for me, and these are the three things that I exactly found in my area. Just looking at an image or a video to demonstrate this a little bit. So the first thing is variance. So it's, well, you showed the picture already. It's a lot of different items, but you already see the repetition a lot here. So this is an actual robot of us, and continuously the robot is moving from A to B. So it's actually a super simple task for if you look at it from a distance. We're using cameras, 2D cameras and 3D cameras, to actually detect where items are, how to grasp an item, and then to move it to the right next location. And the third point I said, I don't need the perfect solution, because if you look here, I've got a bunch of products here to be picked, and I only need to pick one or two. I don't need to pick one really specific one at one really specific point. I just need to pick one of these and need to place it here quite neatly. But it doesn't really matter where it ends up. If it's in the tote, and if it's like pretty densely stacked, then it's okay. So no optimal solution required. If you look at a robot typically does three things. Well, and a human maybe as well. So we sense things, we see, we use our senses here, we think about it, we reason, and we then decide what to do, and then we act. We move with the robot arm, we pick something, for instance. And I want to use this analogy to talk to you about what we are doing with AI on these three different levels. For this, I'd like to start with the sensing part, or how we call it, the perception part. And that's also the point actually where we are using AI the most. So what we're doing here, and this is a little bit more common, so you might know of these kinds of examples already. For instance, from automotive, from autonomous driving. So what we're doing here is we're using deep learning to detect, to do two things basically. We detect all the individual items here. So we get an image and we detect the contours of the items. We also know that, for instance, this one is partly covered by the other item. So that's also information that we get from the network, because if we know that, then we also know to better not pick this item, because then the other item will move as well. So to detect what the top item is. And what we also get from the deep learning here is the classification. So we know what kind of item it is. If it's a box, or is it a blister packaging, or is it a bag? And we use that information to determine how to actually grasp the item. So that's actually an input for our grasping strategy. So what we have here is a deep learning network that is trained by let's say tens of thousands of images. And when we deployed this in real life, so in the project, what we do is we take a couple of hundred additional images to actually optimize the specific network that we pre-trained for the specific situation, to get better in a specific situation where the lighting might be a little bit different, where we might be using a different setup for the camera, for instance. So we optimize performance with this. The great advantage here, composed to the more conventional strategies to do it, is that we don't need explicit training for each individual item. Because if you look at those challenges, then you typically have at your incoming goods in a logistics warehouse, you need to build a model, a 3D model of each individual items, which is really difficult at Edius to actually maintain. Plus, if you're looking at these kinds of examples with these bags, these deformable items, then it's like impossible to make a reliable 3D model out of this. Sorry again? You mean without AI or with AI? Yeah, so we actually did both. We started without AI, and we came quite to a certain level, but then we did it with AI, and then we really reached performance. I will show you a movie as well, how we are doing that currently. I don't know. There. So I want to tell you two sort of ongoing, continuous discussions that we are having, like challenges that we need to find an answer for. And one of the things is, what are we actually going to train? Because now I explained to you that we are actually using AI to train the segmentation and also the classification. And we're using this information to determine the grasp pose, so where to grasp the item with the gripper that we have on the robot. But we could have also chosen to actually train the deep learning network for the grasp pose. We could also said, let's have the robot do a lot of different grasp poses and actually train the robot the whole grasp pose. And then for me, you get into the area of, so for me, the deep learning model, I'll still see it as a black box. There's a lot of things going on that I still don't really understand why it has taught himself a specific thing, trained itself in a specific way. But there's a lot of things I do know. For instance, if I have a gripper and I have a deformable item, like a soft bag, I simply, for instance, want to press it a little bit firmer into it to have a really strong hold. I could have trained that with the AI, just presenting it a lot of different things, but it's, for me, that's such explicit physical knowledge that I have. I actually want to model that explicitly in my algorithms as well. So what we've chosen to do is actually put these two things, get these from deep learning, so classification and segmentation, and actually have added heuristics and kinematic models actually to combine these to actually determine the grasp pose. And we're getting to really good results. I'm not saying it wouldn't be possible to actually include these two in the deep learning as well. Our competitors, some of our competitors are doing it as well, giving them specific advantages, but also disadvantages. But these are, for me, the really interesting discussion topics that we are having definitely on a weekly basis of where to draw the boundaries of your system. And the second one is about lighting. Because if you work with vision, you of course have lights as well. And if you look at conventional vision systems, about more than half of the effort is going into the lighting of it. Because with the lighting, you can enable that the camera can view or perceive more specific artifacts. So it helps, of course, your algorithms. So we are continuously talking about, should we spend more effort in getting better lighting conditions, because then we have more input for the system to learn, actually, so that would be an advantage. But at the same time, you also have the disadvantage is that you actually start training for specific conditions, whereas the great advantage of your AI network, of your deep learning network, is actually to deal with these variances. So actually I'm quite, because therefore I set the skill to this, I actually don't want to put a lot of effort in lighting, because I actually want to really get the value out of the deep learning system to actually be able to be robust for all these different lighting conditions. Also because if I would add a lot of light, I would immediately also get a lot of shadows. And if I have shadows, my algorithms will probably start really looking at the shadows to determine the one product from the other. But actually a shadow is more like an artifact from the lighting that you added to do it. And whereas I would like to have my deep learning network to be trained on specific product characteristics to determine the one product from the other, because then for me it's much more robust to put the system into any specific project with different lighting conditions, with also shadows from a room where sunlight might be brought in. So this is also an interesting discussion that keeps coming back, obviously, as well. So this covered the first part, the sensing part, perception part, and the second one is the thinking part, which in robotics we call task planning, which is determining what is the next step that we need to do. When we started the company, and I guess still 99% of automation programmers, so to say, are tackling this challenge in with let's call sequential programming. So a lot of if-then-else statements. So if this happens, then do this. But if in that case also this happens, then do that. So we also started off with this. But after 2 years or so, we went deeper and deeper into our applications. In our applications, then immediately you start thinking more and more about exceptions. So how to deal with all kind of different exceptions that you might have, because a user might interfere with the system at each specific point in time. And if you start working out all these if-then-else statements to cover all these individual points, it gets really difficult. So in order to actually really get to the level that we wanted to get, we started thinking of this differently. And we started using decision tree logic, which is part of the AI as well, to tackle this problem. So what we typically do is we have sort of a loop running, and the loop starts with updating all our states. So we know the state of our system. We know the state of the world around us. We know where we are and how we are. The next step is based on the end goal that we want to reach. We decide what is the next step that we need to make. So there's of course a lot of, so from each point you can have a lot of different steps, choices to be made from, let's say, a library of skills that the robot has. So the robot could decide to detect a product, or to move a product from A to B, or to drop a product, or to pick up a product. So there's a lot of subtasks or skills that the robot has, which all needs to be put in the right order to actually fulfill the task. But there's quite a bit of different options to actually get to the right order. So actually to search for the right, sort of the right path through this diagram. And again, I don't need an optimal path. I only need one solution, which is pretty okay. You know, it shouldn't be super slow. So there's an optimization here going on. Yeah, so that's what we're doing. And yeah, it's a little bit too much to really go into detail on this, but that's what we're doing on the task planning, so the thinking part while using artificial intelligence. And I'm at the last one, is the motion planning. There's no real specific AI involved here, but it depends a little bit on the definition of AI, I guess. There's a lot of optimization going on here, a lot of... so basically what we do, on a couple of levels, we continuously evaluate through the digital twin a lot of different options for the robot to move, and then we choose the not the best one again. We just need a solution, but we also don't want to have sort of a really slow solution. So again, there's a lot of optimization going on to find the proper solution for us to have the robot moving from its starting position to its goal pose, which has been determined by this thinking part, to the task planner, as well as from the perception. And then if we have these three things, so the perception, the thinking part, and the motion part, these continuously run in a very integrated fashion. So while the robot is moving, for instance, the perception part is continuously looking, hey, what's going on, and should I actually recompute my movement? So it's sort of in a closed loop, all these three things together. It's in a tightly integrated way how we did it. Some movies. So this is about this fashion that we did. So these are typically, they're a little bit vague here, my apologies. But these are the totes with the, sometimes they are the bags with t-shirts, for instance, here are quite neatly ordered in this way. And sometimes it's like they're dubbed into us. And the camera actually needs to make sense of what the individual items are, because if we pick two items at the same time, then two items get shipped to this e-commerce customer. And well, the customer is happy in the end, but the manufacturer probably not, because it's more expensive. And this might be iPhones as well, of course. So to actually be able to do this in a super reliable way, deep learning was key here. We couldn't have done it without deep learning here. And like I said in the beginning, that by doing it the way we did it, like I explained you a little bit briefly, is that we allow for a lot of variations. So if you think about the previous movie, and if you think about this movie, then a lot of things are different. So it's not a box, but it's a roller cage. The items are different. It's a beast of a robot. You know, this is a robot that can kill you. Hopefully not, but the gripper everything is different, but the software is the same. So about, well, not 100% the same, but about 80% of the software, so the core algorithms are all the same. So it actually allows us to deploy the same software over two completely different applications. This is my last slide. Just to finish up, I want to show a little bit of how we started and where we are right now with AI, because we started with it about 4 years ago, I believe. And at that time, we decided to purchase an off-the-shelf solution, which worked pretty okay for us. And the great advantage is we had a really fast time to market because the solution was there already. We just needed to integrate it. But it got really difficult once we start optimizing for performance, because, like I said in the last bit, these things are. It's not that we do a single shot perception and then we determine how to move and then we move. It's like continuously in a closed loop fashion. And if you want to do it that way, it gets really difficult if you just buy something off the shelf. So we decided to start outsourcing it to a specialized company. Again, thanks Cebus for this. This was some advertisement. To actually get the right skills in, because I didn't have the skills in my company. The great advantage here is that it is easier to get to a specific solution, and of course that also start building up your own IP, which is also good as a company, because AI is becoming more and more essential to our solutions. Interestingly, and I'm still discussing with Daniel on this, we are now moving more to insourcing. And I actually don't want that. I would like to keep outsourcing, because for me that's much easier to just outsource a piece of the things, because I need to do a lot. I don't want to do everything. But we are having a challenge here with actually specifying the KPIs that our supplier needs to deliver on the AI. Because what are the performance measures? That's really like dependent on the benchmark that you give them, But if you give them a benchmark, it's super easy to optimize for a benchmark. So it's like, how are you going to deal with this? And we haven't been able to find a solution. So this is maybe one of the ideas. If you have an idea, let me know. But for now, we decided to more do it, to insource it. So we have a team of Daniel inside my own team. And we will jointly working on it as an integrated solution. That was it.
So we have a quick 5 minutes for questions. So please wait until you get the microphone.
And don't throw that one.
No, I don't think so. Okay.
Well, I have a suggestion for your last problem, because I also notice that a lot of customers that start to work with AI have the idea that if you as a company develop a model, then after a few months the project is done and you just give it as a product and you can use it. But actually, that is not how it works. It's the same with if you buy a Tesla, you also would like to have your co-pilot to be upgraded every so now and then for new situations. So I think in this case that you as a company should more think about a model is a service that you buy from another company. Because every time you have new packages, your environment is different, you have more variation. I mean, that is something that another company who makes an AI model cannot predict. But once it is there, you want to have a quick response and updated model. So
I fully agree, and that is sort of what we're doing right now. But then you get to, this is the fly, sorry. But then you get to cost-based pricing. And ideally, I would like to get to value-based pricing and say, if you can increase my performance with a factor 2, then I'm just going to pay you more. So I'm looking for how to define this factor of 2. I'm looking for the KPIs here to measure performance and to be able to pay my supplier based on the performance he's given me, to give him the right incentive to actually be better and better, you know?
Yeah. We can always set up a meeting for a longer discussion on this, because there are more ideas on that.
Yeah, good, thanks. We had 2, I think. We have many, so...
2 questions I have. One is the robot trained during his working? It's a kind of feedback loop to the robot by AI when he picks the wrong part, as you said?
No, good question actually, because what our customers find super important is determinism.
Yeah.
So if you have a specific behavior, they would like to see that until we do a specific software update. So for this reason, we don't allow yet for online training and online updates of the deep learning model. So it's all offline training. We upgrade the model and then we roll it out over all our customers.
Second question is, I work for Signify assembly. What's the step to bring this towards assembly operations? Because this is really what we are looking for, this kind of, and we have also very unpredictable circumstances, a lot of wires in operation, a lot of things. But when can you bring it to assembly?
Yeah, good question, because I think a lot of the technology is sort of ready for assembly, but if you look at the specific solution, it's a lot different, because typically if you have an assembly line, there's like hundreds of different specific tasks that you want a robot to that you want an individual robot to do. So you start optimizing one robot for really being well at sticking a cable into a plug, for instance, and another robot is actually doing gluing, etc. So we've definitely looked into this, but in the end decided to really go for logistics. So I think it's getting ready, but it's different. It's not that you just translate it, and there's a lot of specific things going on, also in the gripper part, for instance.
Yeah, perhaps a similar question is, how do you deal with feedback? So for instance, if customers find that certain products are damaged in the packing part, you have to deal with it somehow.
Yes, definitely. How we deal with this feedback. So we of course take it into account and start optimizing the. So maybe one interesting specific thing is we try to measure online what is happening. So we try to determine when something is happening which is not okay. So when there is, for instance, an error situation, or you would drop an item, for instance. And what we do with the task planning system that we have, this because we each iteration of the loop, we actually have the complete state of our system. This enables us to actually store, like, for 30 seconds of what the software did, to actually replay the whole thing in our digital twin.
Oh, yeah.
So what we do is, with each specific instance of an unexpected behavior, this gets automatically downloaded to our service department, who actually replays the whole situation and start analyzing it, to actually not wait for the feedback of the customer, but start optimizing the behavior.
Could you then also, for instance, have or directly relate a customer report to a certain instance where the machine picked the item?
Yeah, that would definitely be a good next step. Yeah.
Then you can. That is really interesting.
Yeah.
Yeah.
Thanks. So we have 2 people in the back. Yeah.
So I'm not sure from your presentation, but do you have to care about safety in this situation and the safety aspects of the AI system?
And are you referring to GDPR-like things, or like physical
real
safety?
Real safety, physical. Let's say you're handling potentially dangerous goods, or you're working in a mixed human environment, and you don't want the robot to crash into people.
So the answer is yes and no. So we definitely have to care, but we decided to not include it in any of the smart algorithms that we have. So all the safety is dealt with on the lowest level of the hardware. So we just observe whether the speed is under a certain threshold, and that we don't cross certain borders which are hard coded on the safety PLC level. And all the smart things, so like the AI things, are happening on a higher level in the software, that don't have to deal with safety at all, because it's covered on the lower levels. It is definitely super interesting, because if you would start really diving into working together between a robot and a human, then you do need vision, actually. If you really would like to start avoiding the hit of a human, then you would need to get perception and AI in the safety loop. And I think that will happen somewhere in the next 10 years. I'm not going there yet, because I think it's quite a challenge.
Spatial engineering.
Really, yeah? Yeah, but there's always a driver behind the steering wheel. She says you're not on that level, so maybe you should.
Final question.
But I think the combination, the knowledge sharing between automotive and robotics is super interesting here, because I feel that robotics is much further in the brain part, in the smart things, and that automotive is much further in downscaling for efficiency and safety. So like sharing ideas would definitely help.
So I have a more of a general question. You said that you had to have 3 types of minimal amount. So for when AI would be applicable, and also should not be a too optimal solution that is required. But you gave the example of welding. If you are a welder, then you also need to go to welding school for a long time. Why don't you just give it more time to train in order to be more optimal? Doesn't it depend on how much you train it? How much optimal it requires?
Yeah, I think, but maybe Albert knows better. But I think inherently with deep learned network, you don't get to the optimal solution. You get a solution which is the best sort of in a local optimum. But if you want the optimal solution globally, then I think AI is just not the theoretical approach that you can choose to actually get to the optimal solution. Of course, if you train more, you get to a better solution. Yeah. Fully right. But if you produce a car, you just cannot have that the first weld be like this and the second weld be like this, because that will lead to claim. But there's more automotive knowledge here.
So you just need to be better than humans that you try to replace.
But automotive is already a lot better than humans. So robots are so much better in welding a car than a human already. So.
Okay, I think final question still fits. One question. I see
behind
2 individuals. So my apology for the one who's not picked.
Hi, I had a question about your camera having the shadows. So have you thought about like using multispectral or hyperspectral cameras with minimal lighting?
No.
Okay.
Now, it could definitely be an option to look into that. But again, for me, that again holds for you can start applying more and more hardware, which is super expensive. And currently, our suppliers don't deliver hardware anymore because there seems to be a problem with chips. So I actually want to have more intelligent software to be able to deal with. Because if you look at camera technology, there's from the gaming area, there's great cameras coming available, like a couple of €100, which are still easily to be supplied by manufacturers, but actually need to put a lot of more effort in your software to actually get the same performance out of it compared to your industrially grade cameras.
So thank you, Heiko. Thank you for presenting and a very inspiring story. So before we hand over, Albert, just come forward. No worries. I think what I liked about the story is that what Heiko presented is that all of the audience starts contributing, like spatial awareness about ultra-wideband that's coming available from one of our suppliers here on the campus, where Heiko says focus, really tailored focus on a specific industry that brings value. We also learned around AI that's important to focus rather than just to try to solve everything. But I'm looking forward to discussions on the aftermath, being the networking and drinking, because I feel that we have a lot to discuss. But now we have Albert. Albert is with a very, let's call it, senior individual in the field of Eindhoven. Hey, you're here already for, I said, 2001?
Old guy, you mean?
Ouch. Yeah, I think so. No, just kidding. Hey, Albert, you are one of the first individuals and organizations we collaborate with on the AI Innovation Center. When we were exploring the field of education, you were establishing a curriculum, you were trying to share your knowledge that you have been gained in a few of those companies here around the campus. And you left corporate, and we were just making fun a little bit, you becoming corporate again. So what's going on in VBTI?
So actually I started my career here in this area. There was still at the time that there was a gate around this area, and when you wanted to enter, you needed to say hi to the guard. Then he would open the gate, and you could drive to this area. I worked for Philips Research 8 years, and then 10 years for ASML, new business development. And actually, in 2016, 2017, the hype or the discussion about artificial intelligence started. And at that time, I was working at ASML. And we had discussions that people said, the Netherlands or Europe, we missed the boat with AI because everything would happen in the United States or even in China. And at that time I said, no, maybe that is true, but I also see a second boat. And that is when you apply artificial intelligence to high-tech systems, to mechatronics. Because for me, in 2016 and 17, AI was much focused on, let's say, processing consumer data. We have the Googles, we have the Facebooks, the Netflix. They all do interesting stuff with algorithms, with I always call tabular data, nicely structured. But once you start entering and apply an algorithm into a machine, we already had the discussion about safety. We have discussions about real-timeness. We have discussions about precision. So I think in order to be successful in that area, Eindhoven is the perfect place because we are this is the center of mechatronics. A lot happens here. A lot of machine builders are here. So that was my vision. And then I was in a big corporate, and I wanted to start up a new, let's say, field or activity on this. And I always say I have the very good habit that I'm very impatient. And sometimes in big corporates, things are not going that fast as I like. So I quit my job. I think it was in late 2018. And I started my own company.
Yeah. But I heard recently you have some, let's call it, new capital coming in to support you in your journey.
Yeah, that's true. If you had asked me this 3 years ago, I would say, no, I don't want to have any investment because you want to have the full freedom. And I just want to start as a consultant, as an individual on AI. So I started with masterclasses. I like teaching. I like to explain about deep learning. I'm already now for 30 years in this field. But then you have ambitions, and then you see that some of the projects you cannot do alone. So then you start to hire your first employees. And then you say, okay, with a team of 2 people, that is large enough. But if you enter in this field and you have ambitions, then you will see you really need to have a team to come up with good solutions and good applications that use artificial intelligence technology. And then we were at the point that we are now growing over 20 people. And then I said, yeah, I'm still the oldest guy in the company, because the rest, I think maybe there is a difference of 20 years. And I needed the support of a company that could help me, not only financially, because I think getting finance is always easy, but also a company that can help me in entering new markets and also open doors at machine builders. So VDL is the company that we now have a strategic partnership with.
Great to hear that the ecosystem is working for you.
Yeah, it's working wonderful.
Very cool. So we'll have fun presenting and
yeah. Okay. Now, before I start, I will tell you a lot about myself during this presentation, but I also would like a little bit to know something about you. So I just have one question, and that is that if I would talk about the following terms, like backpropagation, Adam, RMS-prop, ResNet, Inception, PPO, TensorFlow, PyTorch, who immediately understands these terms and say, oh, this is just what I always work with? Okay, that is, I would say 30% of the audience. Well, I have good news then for the other 60% of this audience, because this will not be a technical talk. I will talk about my experience in applying deep learning to industrial problems, because that is really my mission, my passion, and that we worked on an exciting project for the last 3 years. And yeah, we had I always had interesting discussions and meetings with customers, so I have some quotes that I collected during these meetings, and they will guide this presentation. So VBTI, as I said, I left ASML late 2018 to start a company that we now call VBTI. I explained that VBTI is an AI engineering company. And that means that the people in my company, they have an engineering background. Electrical engineering, mechanical engineering. Of course, I have a computer scientist in my company. But in order to apply artificial intelligence to high-tech systems, you need to understand the application. And that means you need to have engineering skills. And then we learn the engineers also that you also have a deep learning toolbox. And those tools you can use if the traditional tooling is not sufficient. So we do the consultancy and we build systems, and you will see some systems in this presentation. We give master classes. We work together with Microcentrum on the master classes, like to educate academia and also companies. And lately, we are developing a product called AutoDL. And I will explain to you what that is. Yeah, so located in Eindhoven at the Strijp T area. A young team, very enthusiastic team. And yeah, 2 of the nice things that recently happened. So one already has been discussed. So we have this strategic partnership with VDL. And the other one is, yeah, we are very proud that we received the Gerard and Anton award a few weeks ago. Yeah, there's really a recognition for the work that we did and are doing. So let me start with the first quote. So actually, I was at a meeting with a customer, and we were saying that since we are using and since we are having deep learning as a tool, we are now doing things in a project that if you would go back 5 years ago or 7 years ago, we could not have done or built this system. And that is really one of the things that is remarkable about the deep learning technology, that artificial intelligence is not new, as I will explain to you. But deep learning is a new trend, is a new technology development. And this technology really enables us to make new types of machine. So you already saw in the previous presentation that because of deep learning, we can build these vision systems that understands that there are some boxes and what is the shape of boxes and orientation and position, and how you need to deal with variations in those scenes. But let's start with explaining why I think that, that we can build now things that we could not build before. So artificial intelligence, it's a very old field actually. It started somewhere in the 50s with the first conference on artificial intelligence. There was a group of 10 researchers, we call them the founding fathers of artificial intelligence. And they had a mission, they said, let's do a workshop and let's think about how we can program a computer to reason in the same way as humans can do. Because if we can do that, we have an intelligent computer system. And in this area, the approach for building such a system was, well, then you need to copy an intelligent system. We have intelligent systems, humans. So what they did here in this approach was, well, actually as a programmer, you went to an expert, and then you asked the expert about situations and what is the action or what is maybe the answer in a specific situation. And you would translate that in what we call if-then rules. If this, then that. It's the kind of decision tree that also Heiko showed. Yeah, you start with a point, you start with a question, and then you translate and you make a decision. This is talking from here. Still, interesting algorithms were developed here. Everybody who came here with a navigation system used algorithms that were developed in this area. But there was also a limitation. Because yeah, if you just copy the information and knowledge of an expert, then that's also the limitation. And then another wave in the field of artificial happened. Namely, people started to develop algorithms that actually improved their performance by using data, sensor data. A lot happened also in this area in the field of robotics. That was all to overcome the problem that if you do an interview with an expert, yeah, that you always miss information and maybe the expert is not right. But if you use direct data from the environment of the problem itself, yeah, then the algorithm can directly adapt to that specific situation. Currently, we are in the area of deep learning. And deep learning, it is based, its foundation was made here in this area. And the biggest difference is that now we have a lot of compute power. And I will show you how much compute power we currently have. And if you combine compute power with the algorithms that were developed in this area, then you can do wonderful things, and that is what we call deep learning. So I will go back to 3 moments on this timeline. First, I said I have 30 years of experience, so I will show you actually a video of my master project on artificial intelligence that I did in 1996. I started studying in Enschede in 91. 1 year later, there was a student who told me that he was working on things that could learn. That was really like, how is that possible? And ever since that moment, I was always involved in artificial intelligence. So this is the first thing I will show. Then I came here to this area in 2001. And in 2004, I was leading a project, or actually a startup, on the iCat user interface robot. It was a product that we developed at Philips Research with the idea that we should give technology a social interface. So I will show you this project and also tell you something about AI there. And then we go to 2020 and tell you about a project where we want to develop a robot to cut the leaves of cucumber plants. So how did artificial intelligence look 25 years ago? I have a movie of that. Still thankful to my father, who found this on the attic. So it was on a tape, for those who think, why is the video quality so bad? I think it was a high 8 tape. So what you see here is, I also have a control engineering background. And one of the traditional control problem is, how can you balance a pole that is attached to a car, and the car can go to the left and right to compensate for the falling. In that time, I learned about artificial neural networks, that are algorithms that can adapt using data. So here you see, it's a real-time system. I start with just having the pole in balance. And then while the car is driving, actually the neural network, the algorithm, it learns the dynamics of this car and immediately compensates for when the pole is falling. And we did this at, for those who are still technical, so we programmed this on a DSP, and we managed to have 80 hertz of sample rate, which was quite high at that time. And we did it because we use local learning instead of global activation functions. So that's only for the technical people, but for the others, you can forget that. The most important thing here is that, well, we had artificial intelligence, we had neural networks, we had learning systems, and we applied it to a system. And then the project was over, and industry did not take it over. So we went to some companies, even Philips, and I think at that time also already at ASML. I think only a small part of these ideas were used to make linear motors to remove disturbances. But actually it was not a big hype. We did not have these events that people were really like, wow, what a technology. But the foundations was there. So let's go to 2004, 2005. I worked here at Philips Research. I worked on in the group of software architects. In the beginning on what we call software agents. It was also a hype in this field of artificial intelligence. It would change everything, but nobody ever sees the agents anymore. And then I was involved with this project, where I actually made it a product that we sold to research institutes for doing research on social robotics. So this is the iCat. iCat is a robot with a fully animated face. You will see a video, full of sensors. And our vision was that we need to program iCat to interact with users. And I will only show you a part of this video. And with this video, we should have a little bit of sound if I start. So it will start in a few seconds.
iCat is a user interaction robot for studying intelligent behavior and social interaction styles in the home, aimed at developing software technologies for decision-making and reasoning. iCat's interaction style is modeled after interaction between humans using speech, facial expressions, and intelligent behavior. In this example, iCat acts as a game buddy.
Hi, my name is Katie. What is yours?
My name is Anne.
Nice to meet you, Anne. I like playing games. Would you like to play one with me?
Okay.
Good. Then I may have a nice game for you here. Let's play. The game is called tic-tac-toe. If you place 3 crosses in a row, you win. If I place 3 knots in a row, I win. If it's your turn, my ears and paws will give a blue light. When it's my turn, they will become yellow. Do you understand the game?
Yes.
You may start by placing the first cross. Go ahead and good luck. Good choice.
A socially pleasant...
Yeah. So it was a wonderful project, this. I think one of the highlights, besides VBTI, this was a really great project to work on. But we were not talking about artificial intelligence here. We were talking about perceived intelligence. Because if you look at this movie, then you think, yeah, this is a smart system, and this is 2005. But actually, in this setting, there was somebody who was sitting in another room, pushing the buttons. And why? Well, we were looking for algorithms for computer vision to recognize faces and facial expressions. It was not there. We really looked at it and talked with other researchers. The technology was not there. We were looking for speech recognition. Philips had some speech recognition, but yeah, it did not work. It was also not there. We're looking for algorithms to automatically generate these motions so that they are lifelike. It was not there simply. The technology was not there. So we could make a mock-up. We could do the manual programming of motions. But yeah, if you would have seen this robot for a second time, you would see that it has the same motions. And with that, the perceived intelligence would drop down. Because if you see the system behaves exactly 2 times, 3 times in the same way, then you perceive it as an object, not anymore as something that is intelligent or has a personality. This is only 17 years ago. If I would do this ICAT project all over again now, we would have all technologies for recognizing objects, for programming, speech recognition, etc. So now, and why is that now that we have all this technology? Well, the difference between 2005 and the moment that we are here, or maybe, let's say, the difference between my graduation and the moment here is the following. In my graduation, I had a Pentium computer. I had a hard disk of 500 megabytes and 4 megabytes of RAM. Currently, on my Mac, I just bought a 16 terabyte of hard disk and 64 gigabytes of RAM. So that means a difference of 32,000 times more storage capacity for the same price. If I do the same for the compute power, it was a Pentium. So we talked about 100 megaflops of operations. Operations means how many calculations per second you can do. Currently, we can do 6.2 million times more operations per second than I could do in my graduation time. We have currently better algorithms. When I graduated, I needed to program all the advanced algorithms myself. It was fun to do, but it does not scale. Currently, it's all there. You go to the internet, you download an algorithm, and you can train a model. We are really spoiled. Luckily, we are spoiled with the open source communities, the Python, the TensorFlow, people sharing information on internet. If there is a new paper on a model, then the next day you can download it from some repro, and you can immediately continue the research and work with the models. That really accelerates development. So for me, I always call this is the deep or the perfect AI deep learning storm. All technologies came together. And if you combine it with the ideas that we had in the 90s, then now we have deep learning. And what can you do with deep learning? Well, look at these images. This is what we call generative modeling. So these images are from people who do not exist. There is an algorithm that can just produce realistic images. Interesting thing here is that if you would have a look nearby, then here there are still some artifacts in the image. But yeah, there is a very nice YouTube movie, is 2-minute papers. And there is a quote that, well, 2 papers down the road. And you have a better solution that actually removes the artifacts. So developments in this field, that really goes fast. Then in the area of planning and control, let me see. Yeah, this is, Heiko also already mentioned and touched the topic of programming robots. Well, here you see a robotic hand. The hand has 24 actuators. And the task is to solve the Rubik's Cube problem. As a control engineer, I know that it is almost impossible to program a system that has 24 actuators and to let it solve a task like, well, solving the Rubik's Cube. But currently we have AI algorithms, reinforcement learning, digital twins, simulation, a lot of compute power. And actually they are training in simulation solutions that the system can solve a particular task. And then they need to transfer it to the real robot. This is still on a research level. I always say that low-hanging fruit for a business for deep learning is always on the vision part. It's mature technology, you can do a lot. This will come. But we still need to solve some issues. And then the other one, natural language processing. Maybe you recently heard about DALL-E or Imagen. So you go to this website and you type in an astronaut riding a horse in a photorealistic way. And after a few seconds, you get all kinds of images generated by an algorithm. It's something that was impossible 10 years ago. Now it is all possible. So the third moment in time is that in 2020, I got a customer, VDL, And they had a vision. They said, well, we want to develop a robot for cutting the leaves of cucumber plants. And can you help us with developing a vision system? This is typically a scenario, and I call this a visual jungle. This is so hard to solve with computer vision, traditional computer vision algorithm. So you need deep learning for that. And that's a project that we have been working on, and I will show you how far we are with this project. Now, another quote is that deep learning cannot be learned in a 3-day course. So I also meet companies, and then they have an ambition in AI, and they appoint one of the personnel, well, you should develop an algorithm. This is not how it will work. The technology is quite complex. So as I explained, it are algorithms that learn from data. And why are the algorithms so interesting? Well, they are interesting because if you have more data, then your model becomes better and better, even better than traditional approaches that we have. And there are a few steps in developing an algorithm. So the first step is actually in collecting data. So here you see my colleagues, they go to the greenhouse to collect data, taking pictures of the stems of cucumber plants. But then, in order to make an algorithm, somebody needs to tell the algorithm what is good or wrong. And we call that annotation. So for every picture that we have, somebody needs to put, in this case, a yellow bounding box around what we call a node. That's a place where a leaf is of a plant. And here you already see there is a lot of variation in plants, even more than in this industrial logistics setting. Although there you have a lot of variation in the class of objects, different types of boxes and bottles and bags. Here we have the same object, it's a plant, but we have a lot of variation in the individual plants. If you have the annotations, then you can start training. You need to have some compute power for that. The output of the training is a model, and the model, you can deploy it on the robot, and then the robot can understand the plants. And in the beginning we thought, we're done. It's a nicely linear process. And that's where it goes wrong. Because it's not a linear process. And that's good for companies like VBTI. And that is a little bit, I would say, bad for my customer in the sense that this is a continuous process. So you should think about these models as AI as a service. You constantly need to update these models for most applications that we are working in. So if we look at what we encountered is that if you develop a robot, you can use a traditional engineering approach. We have a problem, specification, and then you develop your first prototypes, and then you iterate. Because every time you have a prototype, you learn something about your problem. But in the solution itself, actually, there is another cycle, and that is the deep learning cycle, the deep learning development cycle. We need to collect data, and we need to retrain a model. And there's some interesting interplay between those two. I can tell you more during the lunch about if you have an engineering team and an AI team that needs to work together on what things can go wrong and how you should let's say, work together in order to have good control over the two development cycles. But it is something new in this field of AI engineering. It's not like you develop a simple algorithm and implement it. It's a big thing to make a deep learning model. We have been working for 2 years on a model that looks at the cucumber plant and detects the leaves. So it's a big investment. And there's also a lot of technology involved. I just wanted to add one slide where there is just a lot of terms, just to impress you that if you start with deep learning, you should know about a lot of technologies. And also you need to have a team, DevOps, MLOps, your AI engineers, your normal engineers, in order to make it a success. Another quote, and by the way, all illustrations in my presentations are made by an AI algorithm. Training a model with 80% precision is easy. Getting to 99.9997, it's the real challenge. You know, it's so easy, as I explained to you. You go to internet, download a script, and you can train a model. Everybody can do it. And maybe if you're a company looking for some party who can help you, you know, they do this. Within 5 days, you have first result, and then you think, yeah, they are knowledgeable. That's not the case. you need to go to the 99.9997%. Why? Well, let's take our case of the cutting the leaves of cucumber plants. So in this case, the robot, let's say it should cut 1,000 leaves per hour. It works 8 hours per day. We have a season of 180 days. That means that after 180 days, all plants are removed and the grower will install some new plants in the greenhouse. And we are allowed to have 5 main stem cuts, because that's of course the danger of this device. It should cut leaf stems. If you cut the main stem of a plant, then you don't make friends with the grower. So if you do the calculations, it is 5 wrong predictions out of 1.4 million is allowed. And that's where this number comes from. So how can we do this? It's even difficult with traditional engineering techniques to get to these numbers. And how are you going to do this with deep learning? There is another issue. I will explain, I will give you the answer, but there is another issue. So if you have developed an algorithm and we go to greenhouse A and we have collected data and we train a model and the robot is able to cut the leaves. Now we go to greenhouse B. It's another customer of my customer, another grower, another greenhouse, different situation. Heiko called this also variation. There's a lot of variation in data. So if you go to another greenhouse, in this case, a greenhouse with LED lighting, different lighting, we did not train for that. So that means that if you have your robot with the vision system trained on data from greenhouse A, the performance will be worse if you go to greenhouse B. So there is a lot of variation in light and plant and background. And you need to compensate for that. Actually, you need to retrain models for those situations. Collect your data and retrain. And that is the approach with how you can make models better. You have model, and you can change what we call the model architecture. You have different type of algorithms that you can use to do a computer vision task. But secondly, once you have chosen for a particular architecture, you need to collect data in order to make that specific architecture perform better and better. Now, let me tell you what we have learned about collecting data and model performance. I have also papers on this. This is an abstraction, but this is a trend that we see when we train models. If you have more data, then actually your model performance goes up. So in order to go to the 99.9997%, collect more data. Easy. Now I go to the customer view. And for that, I rotate my graph. I did not change anything of the graph, but now I have here that my customer is interested in what is the model performance, because I don't want to cut main stems. So here we have model performance, and here we have the amount of data. Interesting thing here is data is money. Because for every picture, every new data point that you want to have, you need to collect it, but those costs are not the highest cost. You need to annotate it. And annotating data, and particularly in the beginning, nobody had a clue on what the cost is of just annotating a picture. In the beginning, we were doing it ourselves, but we are talking here about thousands of pictures. Nobody in my company is enthusiastic about 2 things. They are enthusiastic about a lot of things. But if I again ask them, can you go to the greenhouse? Some of them work at home, so they don't hear the question. And if I say, do you want to annotate? No, it's a boring task. And I think that is fair, because I think they have better skills to do other things. So we outsource that. There are a lot of companies who just annotate data for you. And what we have learned in practice is that annotating one image for a specific task is between 1 and 10 euros. That means somebody needs to add the annotations, but there's also a quality check. And in the end, this is just a number, a range that we find in practice. So if we have, let's say, 10,000 images of a new greenhouse, then that means they have 100,000 euros on annotation cost. This is a really bottleneck for this field. It's still the way how we work, but it's a bottleneck. So where are we? Yeah, this is a video of the result of our algorithm of last year. I cannot show you the latest result. There is some IP discussion here, but this I already can show you. What you see here is, I call this a kraaienpoot. Not sure what the English word for that is. But you see 4 circles, the red circle, yellow and blue circles. The red circle is exactly at the center point of a node. Yellow circles are located, according to the algorithm, on the main stem. And the blue circle is located on the leaf stem. Now here you see the mesh. It's the cucumber jungle. We don't do anything with lighting. We always use natural light. Then we have a sensor. You saw it next to the laptop. And here you see the predictions. This was at the phase that the algorithm did make mistakes. Obviously, we improved on this a lot. But here you already see the workings of this one. And I also there illustrated that we are using 3D information because we need to know the position and orientation of leaves. And if you do a combination of deep learning and 3D data, then you can get these nice, what we call a point cloud. And there's all information that we need in order to engineer a system that the robot can go to the leaf and cut the leaf. And more than 2 years of work. But it's starting to work now. So deep learning is not easy. Data is not the new gold. It's a haystack with a hidden golden needle. It's also this nice quote, data is the new gold, and companies, they are collecting data. They don't know why, but they have huge databases with data in the hope that somebody will come by and then say, yeah, I can turn that into gold for you. Data is a nightmare, really. And that's why we are developing a product that we call AutoDL. Because if Heiko also told you that, a lot of companies and a lot of sectors, they have an issue with labor. Also here in greenhouses, you have the problem that there are not sufficient people who want to cut the leaves. So automation seems like a good idea. But then in order to automate, you need to have a deep learning model. And I'm convinced that deep learning models, they are never done. You always need to update deep learning models. Actually, that means that for every system, or for every so many models, you need to have an AI engineer. Finding AI engineers is even more difficult than finding the people who can do the work. And that's the reason why we develop this platform. So this is a platform to actually to automate the AI engineer. So if we develop a model, so we have a customer with a robot, and the robot cuts leaves at the greenhouse, then when the robot is operational, we constantly collect data, but then we have the problem that, you have so much data, you need to annotate it, so the annotation costs become high. So we are now researching algorithms that actually can select a few images that the algorithm thinks add something to the learning process. So don't use all data, but use that type of data that really adds something, like the failure cases that you encounter. The same is true with annotations, but there are also some trends in order to use other techniques that annotations are not needed anymore. Self-supervised, unsupervised, semi-supervised. And then comes the easy part, training and the model deployment is just good DevOps and good IT engineering. My final movie, this is not the end system. Again, I could not show you the latest system, but we are now cutting autonomously leaves of cucumber plants. And this is just an illustration of how that could look like. But I always say, we already took off. We are flying now with the machine with the first leaves that are being cut. And we are now ramping up, trying to get to the 99.9997%. And getting to a good productivity number, so that also the business case is sound for my customer. And this exactly is one of the projects that I would say that if I would go back 5 years ago, we did not have the technology. And now with deep learning, we have a toolbox that we can build these wonderful systems. Thank you.
We have time for 1 or 2 questions.
Okay.
So we can run late into the let's go break, but let's take a few questions.
Yeah, my name is Amerika. You haven't mentioned synthetic data. because I understand that in your application, not cutting the main branch is very important. It could be a killer for the application. Can't you use synthetic data for that?
Yeah, we use synthetic data in the beginning. So what we did is I went to the greenhouse and made a 3D scan of a node structure. And then you have a 3D model, and then in some program, a Blender, you could just make variations for camera positions, camera lenses, lighting. Worked wonderful for that specific branch. So the thing that I forgot was that branches also have variations. And then you come in the area that if you are having a natural biological objects, that modeling the variation of that object is an issue. Actually, we are starting a new project on this because I also believe that synthetic data can be very helpful, but I'm also somebody still needs to convince me that it will, let's say, replace the normal data that you collect. But I think it's a very valuable addition to generating data for low cost.
Yeah, because I was really scared by the annotation costs.
Yeah. I think
it was so expensive.
There were more people. They were surprised about this cost. Actually, when we started, and then of course we as a company also started very naively with applying deep learning. So we understand AI, we understand deep learning, and then we convince the customer that we think we can do that with this technology. Actually, down the road, you learn a lot, and this is indeed one of the learnings that you then encounter. And if you look to these applications, so I also have a customer who is into the prediction of kilograms of strawberries, but they start in the Netherlands, but then if they have a customer in Spain or in the UK, they need to build up a full new data set, which also means the annotation cost. And that I think you should, at least at this time area for the next 5 to 10 years, you need to take that into account if you make a budget for your own AI project. Yeah.
Thank you very much for an amazing and inspiring presentation.
Thank you for the compliment.
I think the word you were looking for on the plans was a bifurcation.
Yeah.
At the Fontis Applied Mathematics course, we actually worked on cutting leaves for tomato plants. So
okay.
Maybe we can talk about that further. I'm actually involved in determining a profile for a new master's on a professional master on Applied University. And my question is, the profile aims towards educating AI translators. An AI translator would be someone who studied agriculture, for example, and then does a master in, the direction of AI translation. Do you think that would be an opportunity, or are the domains sufficiently helped by the VBTIs in this world, for example? What are your thoughts on that?
Yeah. No, I don't need to fall in the wij van WC Eend trap. Let me first react to the last question. As I mentioned, deep learning is quite a complex technology, and a lot of companies, in particular MKB companies, the smaller mid-sized companies, building up this competence in your company is a too huge investment. So that means that you need to go to specialized companies. The other thing is that this field is really developing very fast. I mean, every quarter there are new algorithms, there are new techniques. That is something that if you are in production in a company, then you don't have time to really catch up with all the developments. While specialized companies, C-Boost, VBTI, there are maybe some more companies, they have the team who actually are just catching up with all the technology. So I really believe that at least for the smaller and mid-sized companies, that cooperate with the specialized AI companies. Of course, the bigger corporates, they always have sufficient resources to build up their own teams. Although I still see there that smaller companies are much more agile and can react often quite quicker than the corporates. For your first question, related to your AI translator, I think in any case where you have a company or a party that cooperates with an AI company, you need to know something about the technology. So I also have difficulties with my customer with explaining actually what we are doing. So my customer is paying a lot of money for the stuff that we do. And then I can talk about the terms that I started with during this presentation, but that is not helpful for my customer. And that's also a difficult thing that, how can my customer trust what I'm doing? Of course, I'm an expert, so you cannot always be in all details, but still, there need to be a trust and understanding. And I think this would help there if people are educated on the topic.
Yeah. So rather a full course than a 3-day course, basically.
Full course, always better.
Yeah, thank you.
Thanks. We have one final question in front of the audience. Yeah.
Thank you. Yes, I was wondering, with all this, the learning going on, is it ever possible to protect your solution by applying for a patent?
That's an interesting question. So we tried to apply for a patent, but that was not specifically on the AI algorithm, but more on the combination of how you can use deep learning technologies and 3D sensors for a specific application. But a lot already happened in that field, so we did not get the patent there. Yeah, but I'm also not, let's say, a patent expert of what part of your ideas you can protect. Related to this topic, because there's also a lot of discussion about data, who owns the models, who owns the result, how we work, but that is more like, as a company, you decide how you want to work with your customers. So we always say the data is from my customer. So I don't use your data in other projects. I don't use your data to sell it to another customer. Then also, if you do a training, I use the word model architecture. That is something that is generic. We invent sometimes architectures, and we say every customer is allowed to use the architecture, so you don't get any exclusive rights, but you can always use it. And the end result of a training session, that is what we call the weights of a neural network, that's also owned by my customer. And that's how we deal with IP. And then within the company, as I said, so we are now focusing on these algorithms to select data. It was on this part of this diagram. Yeah, I think the best protection there is in the beginning, of course, don't explain on how you do it. If I have an algorithm that can reduce cost with 90%, then as a business you can work on that. But I think also in this field that the time that you can protect an idea is so short. So rather be the best and always deliver quality. That will help your business more than that you really try to defend your technology.
Thank you.
Thank you. Thank you, Albert. Thank you for presenting. This afternoon we have a program, I think, that will answer some of your questions around technology and ecosystems, right? So rather doing 3-door course or in-source, outsource, or have the right sourcing model in place. And I think even our last roundtable will be around legal and ethics and how you can protect your potential IP or not. Right, so thank you for joining. I think break starts, food is downstairs, and yeah, enjoy the lunch. Thank you very much.